Hi class, this week we're going to be covering chemical reactions and equations. So we have objectives. Let's point out some of the ones that we're going to really spend time on is the type of reaction from its chemical equation and the type of reactions to predict reaction products. So let's understand a chemical equation. Chemical equations always have a reactant side and a product side and an arrow in between. If we have more than one reactant, then we use a plus sign to separate them out. We have an arrow. This arrow means that there's a reaction that is proceeding. If there's products on the side, then a chemical reaction has occurred in most cases. And if there's a triangle above, it means that heat was used to cause the reaction. And then we have physical states, which I put here. We have aqueous, which means an aqueous solution. We have a liquid, water is a good example, a solid, and a gas. Signs of a chemical reaction has occurred. If you're not really familiar with signs of a chemical reaction, I definitely suggest you look this back up and make sure you're very familiar with this. Knowing these, this information really does help in understanding reactions when you read them. So let's start with warming and cooling. When you are doing a reaction, you can sometimes see heat. You can feel some heat coming off. You can use a thermometer to determine the beginning temperature and the final temperature. This also helps in understanding if a reaction has occurred and if it is gone down in temperature or if it's increased in temperature. So heat being given off or heat or you'll feel a coolness to it. A change in color is another sign of a chemical reaction. Next week, we're going to do a titration, and that involves a changing of a color of a solution that will let us know when the chemical reaction has occurred. Formation of bubbles is a gas leaving a chemical reaction, and bubbles, fizzing, sometimes you'll hear popping, those are gases leaving. And formation of a precipitate. A precipitate is a solid, but a solid is kind of loosely defined here. If you think of a solid, you think of something like a rock, but a precipitate really means is a change. So if it can be an actual solid form, or it can be particles stuck in suspension that are very, very small. You need to look at, it's usually a cloudy solution. So you went from a clear solution to a white cloudy solution. And if you look real close, you can see little particles in it. It's opaque. It's not clear. You can't see through it. That is also considered a precipitate. And even though this one's not really covered on here, it's a sign of a chemical reaction for this lab. I'm going to point it out as a metallic deposit. So what we'll see is we'll start out with one metal and you'll see that metal change as reaction occurs. And we're going to see that today. Type of chemical reactions, we have synthesis, where you start with two reactants and you end up with one product. Decomposition is the exact opposite of that. Single displacement or replacement is you have one reactant by itself, and it basically kicks out one of those reactants on the other side that's next to it, and it forms a new compound. Double displacement, we're going to spend more time on this one because there's actually three types of double displacement. There's neutralization reactions, precipitation reactions, and gas forming reactions. And they are switching partners, and I've given you examples here. And then a combustion reaction has to do with hydrocarbons. That's a carbon and a hydrogen, fancy name that's put together for them. In the presence of oxygen, these little boxes were triangles, and in the presence of heat, produce CO2 and H2O. So let's spend a little time with single displacement reactions. Single displacement reactions replace one of the cations in a compound. So A is usually a metal and it's usually a solid, and what it'll do is it'll kick out the cation on that's usually a metal or hydrogen. The hydrogens also can be in single replacement reactions, and kick it out, and that B will be by itself, and it could be a hydrogen gas, and then a new compound is formed. So if the metal is more reactive than what is here in a compound, the reaction will occur. And how we know that is by looking at a hierarchy table. So let's take a step back and let's break this down a little bit more. So here is magnesium. If magnesium is more reactive than aluminum, it'll kick it out. So you see where it was a solid. Now aluminum is a solid, and we have magnesium chloride in aqueous solution. So this tells me that magnesium was more reactive than aluminum, and it formed aluminum solids. So that's where you see that little deposits on the metals. They change the way they look. So here is, again, another one, and you can actually see a formation here. So we have copper solid in the presence of silver nitrate. And the physical science, the physical states also tell you exactly what's happening. You don't even have to look at a solubility chart on some of these. Here, we won't really look at a solubility chart. We'll look at the activity series as well. So here we have copper solid, and in the presence of silver nitrate, it produces copper nitrate and silver solids. So that's where you see the copper wires here, but you start seeing silver formations on top of the copper because it's changing places. So displacing metals, once a piece of copper is placed into silver nitrate, metallic silver ions form on the copper. The solution will turn blue because copper atoms from the wire dissolve into solution and displaces the silver from the silver nitrate. Copper too tends to be blue. So it could be this way where now you see a blue solution and you see this formation of silver. But it can also go the other way where you have copper solution in the beginning, and by the time you're done, the copper has went into a solid and the blue has gone out of the solution. So, but this all depends on the activity series. Whatever is above can kick anything below out, but whatever's below can't kick anything above. So here is copper solid in the presence of silver nitrate. Copper is here, silver is here. So copper's above, it kicks silver out of its seat, takes over, and now silver's by itself. It's a solid. So copper being more reactive wants to be in the more stable form. And this is actually the most stable form for it when it's in the presence of another metal that's lower than it. So let's go back. If this had been reversed and silver had been in a solid and copper had been here in a copper nitrate, which would have been a blue solution, nothing would have happened. The silver would have just stayed silver because it's below, so it cannot kick the copper out of its place. Double displacement reactions, we have 3 types. We have precipitation, neutralization, and gas evolving. Now we can have actually a 4th that we don't really talk about, but it's down here in the corner. Double displacement is switching dance partners. So either the cation switch or the anion switch. But sometimes you'll get something that nothing occurs. So once you look at the solubility chart, you'll see that there's aqueous, 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 aqueous. It's no reaction. All these ions are just swimming together in solution. And that happens. But sometimes you will still be asked to complete the whole balanced equation to show that you understand what's happening. So make sure you know whether they want no reaction or do you have to complete the whole equation. Here's a solubility chart. I'm going to show you really quickly how to do this, how to read these. If you haven't, I definitely think you should spend time making sure you're comfortable with these. You can Google solubility charts and you will find 3 million and they all look very different from each other. So you have to spend some time to make sure you're understanding what you're looking at. Ions that are soluble in solution, that means that they will just stay in solution. There are no exceptions. So nothing that these are attached to, they're going to stay in solution. I apologize if you can hear my cat snoring in the background. She's an older cat. See, I don't know if you can hear her. Anyway, she's snoring. Ammonium will not attach. It'll stay in ion form in aqueous solution. So all of these will stay in aqueous solution. Halides will as well, except for if it's attached to silver, lead, or mercury. Then it'll turn into a solid. Sulfates will stay in ionic form in aqueous solution, except for when it's attached to these. So look for the word soluble. If you go on the other side, insoluble means that these are going to stay in solid, except for if they are attached or combined with the exceptions here. Then they will stay in aqueous form. So carbonate will stay in a solid unless it's combined with a group 1 or ammonium. Then it'll be in aqueous form. Chromate will stay a solid unless it's attached to one of these, and so forth. So this is how you have to make sure you understand reading this, because reading it wrong, you could mess up your whole double replacement reaction. So let's look at a precipitation. Now remember, precipitation doesn't necessarily have to be in a solid. It can be a cloudy solution with small particulates stuck in suspension. There's a range of what you would see. If we had been lab, you definitely would have encountered this. When you're given some information, make sure you read it, because sometimes just the reading of whatever's given to you tells you everything you need without even having to look at a solubility chart. When a yellow aqueous solution of potassium chromate is added to a colorless aqueous solution of silver nitrate, a red precipitate of silver chromate is formed. It has given you everything there. So if I was to give you that sentence above, by now you should be able to write it out with the physical states and balance it on your own. And it may take a while. It's not always easy, but you definitely should be familiar with a lot of these chemical compounds to be able to put them in form, put them into their ions, and then switch them into partners. Then look at the solubility chart. So let's look at it with the reading. First thing it says, when a yellow aqueous solution of potassium chromate. So potassium chromate is here, and it's already telling me it's an aqueous solution, so I would put an AQ. Is added to a colorless aqueous solution of silver nitrate, AQ. And then produced a red precipitate of silver chromate, solid. Precipitate, solid. And then the remaining ions are in aqueous because they had nothing to do with the solid. But let's say you didn't have that. Then you would have to look at a solubility chart. So we would look at chromate. Chromate is insoluble except for in group 1 ions, calcium, magnesium, and ammonia. So it's insoluble. It's aqueous here because potassium's group 1. But when we have it on this side, it's attached to silver. Silver is not an exception, so it's going to be a solid. Nitrates, nitrate and nitrate. No exceptions. So wherever nitrate's attached to, it is an aqueous form. Here's another one. I will let you take a look at this one yourself. Look at the chart, see if you understand what it is, even though I've actually highlighted the groups. Not every compound is going to be on a solubility chart, but it should be connected to something that is, and that will give you your information. Here's the answer. Now let's get into neutralization double displacement reactions. We're going to do a titration next week, and that's exactly what this is. This is a double displacement. It is with an acid and a base. Now keep in mind, we know sodium hydroxide is a base, but there are other bases that don't look like sodium hydroxide with the OH. Because we're at home, I'm not requiring memorization on any of these things, but you definitely should know what strong acids and strong bases look like. You should have those memorized. If we had been in person, you definitely would have had to know that information. So here is a reaction that is an acid and a base, and it always produces a water and a salt. Now salt, in this case, we used sodium hydroxide and HCl. But salt does not necessarily mean NaCl. What it means is the leftover ions that were not included in the water. It's just a generic term. So let's go on to the next page. You can see here there are some acids and there are some bases. And the salt is a metal and a non-metal, so the potassium nitrate, and the water is produced. So you see you have an acid, a base, it's a neutralization reaction. That's where the neutral comes from because it produces water, and the leftover salts. Gas formation. These tend to be the hardest to understand because they don't come up as often as other ones do. So let's break this down. I apologize, this all moved and I should have fixed it. A reaction that produces a gas from reactants not in the gaseous state. So something that wasn't in a gaseous state in the reactant side. Some aqueous reactions form a gas as a product. And there are 2 steps to these. This is what makes these confusing. I have more slides to give way more examples of what's going on here. The first is the double displacement reaction. So you'll complete the double displacement reaction and you'll get a weird product you've never seen before, like this. And you don't know what to do. Well, these are unstable. They're not going to stay. If you left them as this, it would be incorrect. These, carbonic acid is unstable. It will decompose to water and CO2. This one, sulfurous acid is going to decompose to water and SO2. And ammonium hydroxide is going to decompose to water and ammonia. So there are things to look for to make sure you understand this. So let's say I gave you sodium carbonate plus HCl. You would have to finish this other side. Once you finish this other side, you get this weird product that you've never seen before. That's usually an indication something's not right. And not on your side. You just need more information. What you need to know is that this is unstable. It's going to decompose to this. And once it does, it's going to produce water and CO2. So your new products in the final equation are NaCl, water, and CO2, and then you balance it out. And so these are the things you have to know, that there's 3 different types of double displacement reactions, and you have to know what they are. Because if you get stuck on something, having more knowledge always helps you find that answer. And double displacements, gas ones and neutralizations tend to be the ones that people forget about. Again, here is more information for you to understand. Sulfides, carbonates and bicarbonates, sulfites, bisulfates, and ammonium tend to give these unstable products that change into something else. Again, more examples of this where you can see the final products instead of the intermediates. So in most books, when you see it, you actually see it like this. They don't show you that there's actually a unstable product in between. This is something, again, chemistry just expects you to know. So make sure you're very aware of which type they're here, and and look these over so you can see this is an acid. This is an acid, this is an acid. So there's certain types that kind of go with this. A carbonate, acid and a carbonate. Acid and here you go. Acids and sulfates, bisulfites, bicarbonates, carbonates, sulfites, ammonia. Excuse me. I'm trying to clear my throat. So if you start balancing, the key thing is if you start balancing, you get this weird product. It's probably a gas evolving. It's a gas reaction. And again, here we have more to allow you to see. Here is the unstable product. Here it is with the correct one. Unstable product. Here's the correct way, and so forth. And then we have a single replacement. Remember, single replacements also give off gases. This is a little different. It's not double displacement, single replacement, but it also does give off gases. So just to give you an idea. Now let's get into combustion reactions. Combustion reactions tend to be the way we teach it, or you have a hydrocarbon in the presence of oxygen, and it produces water and CO2. It's a combustion. There's usually a triangle. Sometimes they show it, sometimes they don't, but it's in the presence of heat, allows this reaction to go forward. However, lab flow, we don't tend to teach it this way, but it is correct. When I teach combustion reactions, I teach with the hydrocarbons and the products being water and CO2. Lab flow wants to add on that the correct term for combustion reactions is in the presence of oxygen. So if you see oxygen as a reactant on the reactant side, they consider that a combustion reaction. They also consider it a synthesis reaction if it's being combined. So make sure you're very aware of this, that a combustion reaction, if it has oxygen as a reaction, a reactant, it is combustion and a synthesis. Balancing equations. By now you should be able to put something completely together, even if it's given to you in word form. And you would have to look up the solubility charts, or the wording of the problem will tell you the physical states. Should have coefficients are what we balance. We never, ever, ever touch subscripts, because if you touch subscripts, you're changing the substance, and then you put it completely together so you can see what's happening. This one's a little weird because you got a solid and a solid. I don't think that's right. I think I was looking for something that just had physical states and I didn't overlook it. So we could pretend that this is aqueous, and then it forms a solid and a liquid and so forth. But having balanced reactions with physical states gives you a lot of information. And then from there, you can determine what type of reaction this was. So we get to our lab now. We have 7 labs, and they don't match exactly what's in the PDF. The PDF is actually asking for more information than you need to do, so just be aware of that. We are going to use the PDF though, or I'm going to suggest you use the PDF on certain parts. So we get to reaction 1, and this is magnesium metal and oxygen. And you would have done this in lab. If you were in Chem 10 before the lockdown, you did this in lab. It was a very bright, intense white heat. When you get to this part of the report, each lab has a picture or a video with it. So you'll have information to be able to complete all this. Now here's, so this one's a video. I don't have it here. I just took a picture of the front page. Make sure you read everything that's here, and you're going to have to balance the reaction on some, and some it's blank. You're going to have to complete the reaction. So make sure I highlighted what needs to be done. If you have to use the subscripts and superscripts, make sure you do. If you don't, it's incorrect. So this is the first one. And you can see here, let's go back. This is in the presence of oxygen. So this might be one reaction, or it might be another reaction. Second one you have is reaction of zinc and copper to sulfate. Again, read this. It's going to tell you something. But here is a new compound attached here. And it also gives you the reaction. So you should pay attention to what this reaction looks like so you can figure out what it is. This one's nice because it's also giving the physical states. So you can see that zinc started out as solid, and now copper is. So what this is that this zinc metal was added to a copper solution, and now you see the blue's gone away, and now there's a new formation. So that should help you in understanding what's happening with this one. Now, this picture does not match lab flows because I don't like some of the pictures that lab flow gave you. They gave you one, and you're supposed to determine everything from one picture. I don't like that. So on this one, this is a reaction of magnesium and HCl. Here's the reaction. It's giving you some information. Magnesium metal in the presence of an acid, and you see a lot of bubbling, and if you were to touch this, it would actually be hot as well. Not to burn your hand. I've done this reaction many times, and you guys probably would have too. And I think this is actually coming up in another lab, but it's one that you could touch it and the beaker would be warm after the reaction occurred. And then all of a sudden you see the metal is gone and no more bubbles are coming off. That means the reaction's done. So if you see here, you start out with the metal, but you don't have a metal anymore. What's produced is a hydrogen gas. That's what all that bubbling was. And now you have magnesium chloride. I didn't like the picture they gave for this one either, so I found this one. This is lead to nitrate and potassium iodide. So make sure you read. It'll tell you something that's happening here. It's actually asking for the balanced reaction. Here's a hint. Your PDF has the reactions. They're not balanced, but it gives you the reactions. So you don't have to go struggling looking for this stuff. But notice these are both clear, and now a new product has been formed. And if you look at the PDF and the balance, I believe they even give you the physical state, so you can actually determine what's happening here. Another one is iron 3 chloride plus potassium thiocyanate. Now this one, they only give you one picture and not the other two. So I found it, and now you can see at least a better picture and understanding of what's happening here. Again, not balanced, not given to you, but the PDF should have it. And lab 6 is a video, which is nice. You get to see a video. This is HCl and hydrogen, sodium hydrogen carbonate. And here you're going to see something evolve. But this one, they did give you something. And you see here, you have what would have been a product of an unstable byproduct, temporary product. That's why I covered this. So you see where CO2 and H2O, if you balance this out, you would get a weird byproduct, and then you have to remember, hey, this is not stable. I have to change it into something else. And the last one is hydrogen peroxide. You have it right here. This one, they give you one picture, and I don't think it really gives you enough information to understand. So this is peroxide, and it produces water and O2. So you should see a gas coming off of this, and water is the product. I did not like the picture. I mean, you guys can see it for yourself. So what I did is I posted a link to a YouTube video of this experiment being done. And they also talk about here, as they did on LabFlow, they bring up the word catalyst. If you're not familiar with what catalyst is, it's a substance, usually an element, that will help a reaction occur or occur faster, but it's not actually involved in the reaction. So think about, you go to Dodger Stadium and you can't find your seat. An usher will help you to your seat and then leave. That's exactly what this is. It will help the reaction get to the product side, and then it leaves. It's still there. It's not used up. And it'll keep doing this until there's no more reactants for this to happen. So that's what a catalyst is. Now in the video I posted, the catalyst is a different color. So it doesn't match the picture, but it doesn't matter. It's actually better because you can see what's happening with the catalyst. The catalyst is colored so that it gave off, when the experiment's done, it also makes the experiment that color. Doesn't matter. You can watch it. I wrote it on Canvas. You can watch it to minute 6:40, and he explains exactly what's happening with it as well. And it's pretty good. You should really pay attention to it and watch it all, because if you're planning to go to Chem 24B, you're going to be doing more of this information. So you may not make sense what he's talking about now, but you should pick up on some of it. And that's expanding onto what you're going to have to learn in 24B. Okay, so here's some tips. Again, LabFlow considers reactants of oxygen by themselves as a combustion reaction, even if the products are not CO2 and H2O. So make sure you understand that in case, hint, it's a quiz problem. Check the PDF for the unbalanced equations if they're not on LabFlow, because some of LabFlow gives it to you, some of them don't. Make sure you complete them with coefficients that are there. And if you have to do the complete, subscripts as well. And the subscripts have to be in subscript form. If they're not, I will deduct. And physical states have to be there as well. Everything has to be complete to the end. And that is it. Thank you.